Welcome to qnawire.
Okay, so this is the force diagram on the ring. So let's take a look at the moments about point O. Consider counterclockwise moment is positive, clockwise moment is negative. Therefore, have the moments at point O is equal to Fa times 75 mm minus Fb times 75 mm is equal to 0, which means that friction at point A is equal to friction at point B. So now we can apply force equilibrium for this question. So the net force along xy direction should be equal to 0. So along the x direction, we have P cosine 60 degree minus FB cosine 30 degree minus FA is equal to 0, which means that P cosine 60 degree is equal to FA plus FB cosine 30 degree. And then the net force along y direction can be expressed as follows, which is NA minus W minus P sine 60 degree, and then minus FB sine 30 degree is equal to 0. And this will give us P sine 60 degree is equal to NA minus W minus FB sine 30 degree. So now remember, Fa is equal to Fb, which means that Na is equal to Fa over mu A, which is equal to Fb over mu A. And this will give us such two equations here. Since we know Fa is equal to Fb, okay? And then we have tangent 60 is equal to P sine 60 degree over P cosine 60 degree, which is equal to Fb over mu A minus W minus Fb sine 30 degree over Fb times 1 plus cosine 30 degree. So if we do some arrangement here, eventually we'll have friction at point B is equal to negative W over 1 plus cosine 30 degree times tangent 60 degree minus 1 over mu A plus sine 30 degree. So we know the gravity of the ring can be equal to mass times the acceleration of gravity, which is equal to 0.5 kilograms times 9.8 meter per second squared, and this is equal to 4.9 Newton. And we know the coefficient of static friction at point A is 0.2. So now we can plug in these values back into the equation. We'll have the friction at point B is equal to 3.86 Newton. So now remember, P can be equal to Fb cosine 30 degree plus Fb, which is equal to Fb times 1 plus cosine 30 degree. Therefore, have P is equal to 3.86 Newton times 1 plus cosine 30 degree, which is equal to 14.4 Newton. So now we need to prove that the rings is slipping at point A. In order to prove that, we need to compare the maximum friction at point B and the friction we have so far. So the maximum friction at point B can be equal to mu B times P, which is equal to 0.3 times 14.4 Newton, and this is equal to 4.32 Newton. As you can tell, the maximum friction is greater than the friction at point B we figured out so far. Therefore, the rings is slipping at point A. So P equal to 14.4 Newton is proved. Therefore, these are the answers for this question.